Welcome back. This is chapter 5.3 of ZTransform. In this subsection, we'll talk about inverse Z-transform. These will be the things that we are going to cover for this subsection. Basically, different methods and approaches to perform inverse Z-transform. The simplest and most direct approach, which is not very practical, is this. We know that we can take the Z-transform of a signal xn using this equation over here, and it will generate a polynomial from this sequence x of n. So a sequence x of n from n equals to 0 to capital N will become a polynomial of power of z minus n, where the index corresponds to the index of the power of z. So in here, we can see that x capital N is associated with z minus capital of n. Therefore, purely by inspection, we will be able to take the Z-transform and map it back to the sequence. So let's do this example. If we are given x of z, let us find x of n. And here, 1 is simply delta n. 2z minus 10 is simply 2 delta n at index 10, delayed by 10. And 3 with z minus 20 is simply 3 delta n minus 20. So to plot this, what we can do is, if we plot this as delta n, delta n, 2 delta n minus 20, and 3 delta n minus 30. So this is the sequence delta n plus 2 delta n minus 20 plus 3 delta n minus 20. And the Z-transform of this sequence is this guy. However, this is very impractical if we have a large sequence of n. It simply shows how we can represent xc in this type of polynomial. Let's see another approach. The second approach is by long division. Now, let us start with an equation that looks like this. Xc is equals to 2. So remember, we will write 2 like this, which is very similar to z, but we'll put a z with a dash in the middle so we can distinguish 2 and z. So it's 2 plus z minus 1, 1 minus half z minus 1. So this rational function represents our x of z, and we are trying to get x of n. So what do we do? Well, whenever you're given such a problem, you must always check the region of convergence. In this case, absolute z is greater than half for the region of convergence, implying that we are dealing with a causal sequence. Whenever you see that the region of convergence is external to the pole, then we are talking about a causal sequence here. And a causal sequence, the Z-transform would have minus n as the power of the polynomial. Alright, let us take 2 plus z and put it here. And we are dividing by 1 minus half z. So what do we do? Well, as the name says, we are performing long division. So what we do is, we want to multiply 2 by this guy to get this expression here, and we are subtracting. So we are performing the typical long divisions as you know in high school. 2 minus 2 is 0. Z minus 1 minus z minus 1 is plus 2z minus 1. So the second time we're going to do this is we're going to multiply by, we're trying to get this expression 2z minus 1, so we multiply by 2z minus 1 here, since the expression is 1 over there. So we have 2z minus 1 times this expression, and we are getting 2z minus 1 minus z minus 2. Notice that because our ROC is positive, we are multiplying by z minus 1. And we are arranging the equation this way so that as we are performing the long divisions, we are getting more and more negative powers of z over here. So you can keep on doing this, and then you will see that you will finally get an infinite polynomial. And now, as we did in the previous example, is that we can take all these expression we have and convert them back to time. So this is 2 delta n plus this guy is 2 delta n minus 1. This guy is delta n minus 2. This guy is half delta n minus 3, and so on and so forth. Notice, however, that we do not have a closed form expression. We are simply taking the polynomial that we have extracted by long division and converting it into a time sequence by identifying each of these expressions. So this is what we have here. Now, you can watch the detailed explanation from this YouTube video link of this example given by Panagos. This is the long division method. In the next few slides, we will see the more common partial fraction expansion method which we will use typically. Thank you.